3.5 seconds off the fastest qualifying pace at multiple points during the 2026 season is the brutal metric defining Aston Martin's current reality, a gap so vast that even if Honda delivered a perfect power unit tomorrow, the team would still be staring at a fundamental chassis deficit that no engine upgrade can fix. This is the uncomfortable truth hiding behind the headlines about horsepower, because while everyone is obsessing over whether the new Zandvoort specification engine will deliver 20 or 50 horsepower, the data suggests the real curse isn't just under the engine cover but woven into the very architecture of the AMR26 itself. So here's the tension that nobody in the paddock wants to say out loud right now. If Adrian Newey's assessment is correct and the team has truly been forced to grow up quickly through this pain, why does the telemetry still show a car that is fundamentally compromised by decisions made before the first wheel even turned in anger? Fernando Alonso having to physically let go of the steering wheel mid-corner at the Chinese Grand Prix wasn't just a scary moment for the fans, it was a direct mechanical consequence of severe low-frequency vibrations transmitting through the entire chassis from Honda's new internal combustion engine. That specific failure mode tells us something critical about the integration nightmare Aston Martin is living through, because when a two-time world champion cannot safely hold onto the car in a high-speed bend, you are no longer talking about performance development but basic operational safety. Early in the season, the situation was so dire that the team was reportedly down to its last two working hybrid batteries with absolutely zero spares available, a reliability crisis severe enough to threaten their ability to complete full race distances around the Australian Grand Prix. You have to wonder how any team can possibly break a curse when they cannot even accumulate the mileage necessary to understand the baseline behavior of their own machinery. Shintaro Orihara, Honda's technical lead, confirmed the scale of the disaster without offering a single comforting number, stating only that when they started running in Barcelona, they realized their performance was definitely poor compared to other manufacturers. Notice what he didn't say. He didn't give a horsepower figure. He didn't promise a fixed date. He simply acknowledged the qualitative reality that the Works partnership had failed to meet the most basic competitive threshold at the start of the year. But here is where the story gets genuinely complicated, and where the narrative of a simple engine swap falls apart completely. Paddock estimates on the actual power deficit vary wildly depending on who you ask and what reference point they use, creating a fog of uncertainty that makes it nearly impossible to separate fact from frustration. Some sources cite a 60 horsepower thermal engine deficit against Red Bull as the benchmark. Others whisper about a 100 kilowatt energy recovery shortfall, which translates to roughly 136 horsepower when including deployment losses against Mercedes. Still others frame the overall gap at 80 to 100 horsepower. None of these numbers match. None have been independently verified by two separate sources agreeing on the same figure, and none come from Honda itself. This matters enormously because if the deficit is 60 horsepower, the Zandvoort update bringing 20 to 50 horsepower could be transformative and genuinely close the gap. But if the real number is closer to 136 horsepower including deployment issues, then even the most optimistic upgrade projections leave Aston Martin significantly adrift of the pace setters. The uncertainty isn't just a lack of information. It is an active obstacle to solving the problem because you cannot calibrate a chassis development program around an engine target that keeps moving every time a new rumor surfaces from the motorhome. Adrian Newey himself admitted he had to change the whole car because the Honda engine didn't fit as originally packaged, meaning the chassis philosophy was redesigned around constraints rather than performance targets. That is not a path to breaking a curse. That is a path to managing damage. Yet somehow, despite sitting near the back of the Constructors' Championship and facing questions about whether this project was doomed from the start, Alonso is reportedly negotiating a contract extension that would raise his salary from roughly €30 million per year to a demanded €40 million annually. That specific incident in China stripped away any remaining pretense that this was merely a performance issue, transforming it instantly into a driver safety emergency that demanded immediate engineering intervention. When the steering column itself becomes a hazard rather than a control interface, the entire development roadmap gets rewritten overnight to prioritize vibration damping over aerodynamic efficiency or power extraction. Mechanics were reportedly scrambling between sessions just to keep the cars running, let alone making them faster, because every lap completed carried the risk of catastrophic component fatigue induced by those relentless oscillations. The physical toll on Alonso cannot be overstated, as absorbing that level of mechanical punishment to his arms and spine for 50-plus laps requires a tolerance that most drivers simply do not possess. He endured it. The car survived. But the data collected during those grueling stints was largely useless for performance tuning because the sensors were overwhelmed by noise from the vibrating power unit mounting points. So where does that leave the team's understanding of their own car right now? They have mileage, yes, but it is contaminated mileage gathered under duress rather than controlled testing conditions. This distinction matters enormously when you consider that Adrian Newey confirmed serious work on the 2026 car did not actually begin until April 2025, meaning the foundation was already laid before the vibration crisis even emerged to compound the delay. You cannot simulate low-frequency harmonic resonance in a wind tunnel or on a 7-post rig with perfect fidelity, which explains why the problem persisted well beyond winter testing and into the opening flyaway races. Honda has stated it is working to identify a root cause, but that phrasing itself reveals the depth of the challenge, because identifying and eliminating are two vastly different engineering milestones. Until the source is definitively mapped, every upgrade package carries an inherent risk of introducing new failure modes or simply masking symptoms without curing the disease. The financial implications of this reliability nightmare extend far beyond spare parts and logistics costs. Every hour spent troubleshooting vibrations is an hour not spent optimizing the energy deployment strategies that define competitiveness under the 2026 regulations, where MGUK output jumped from 120 kW to 350 kW. That massive increase in electrical power was supposed to be Honda's opportunity to leapfrog rivals returning as a full works partner, yet instead it became the vector through which systemic integration flaws manifested most violently. The team's stated goal for the second half of 2026 has quietly shifted from fighting at the front to simply climbing back into a reliable midfield position, a dramatic recalibration of expectations that speaks volumes about the severity of what they've endured. Breaking the curse now means something fundamentally different than it meant in February. It no longer means winning races this year. It means surviving long enough to build a platform that doesn't collapse under its own mechanical contradictions next season. And that survival depends entirely on whether the Zandvoort update can deliver not just power, but the stability that has been conspicuously absent since day one. The sheer breadth of that 60 to 136 horsepower estimate range reveals something far more troubling than simple performance deficits, because it exposes a fundamental breakdown in how information flows between Honda's factory and the Aston Martin garage. When paddock analysts cannot agree within 76 horsepower on the size of the problem, it suggests that even the teams sharing pit lanes are interpreting telemetry through completely different analytical frameworks. Some observers strip away electrical deployment entirely and calculate a clean thermal deficit against Red Bull's benchmark, while others include full energy recovery system losses and land on a vastly larger gap versus Mercedes based on GPS trace overlays through traction zones. Neither methodology is inherently wrong. Both are incomplete without knowing which failure modes dominate at any given circuit, and neither reflects an official position from the manufacturer responsible for building the unit. Shintaro Orihara's carefully worded admission that Barcelona performance was definitely poor compared to other manufacturers landed with deliberate vagueness, avoiding any quantifiable metric that could be used as a baseline for future accountability or contractual benchmarking between supplier and customer. Why would Honda's technical lead refuse to attach a number to such a public acknowledgement of failure? The answer likely lies in the fact that attaching a specific figure would lock them into a development target that their own internal simulations may not yet support, especially given how much the vibration issue has compromised dyno correlation and real-world validation simultaneously. Without reliable track data to anchor their models, any horsepower claim becomes speculative marketing rather than engineering fact, and Orihara knows better than anyone that overpromising now would only deepen the credibility crisis later. So he offered qualitative honesty instead of quantitative precision, leaving the paddock to fill the void with estimates that vary wildly depending on whose spreadsheet you trust. Data contradicts itself. Engineers adapt anyway. Development continues regardless. This ambiguity creates a paradoxical situation where Aston Martin must make critical chassis development decisions based on power unit targets that exist only as rumors rather than confirmed specifications. Newey's team cannot optimize gear ratios, cooling packages, or aerodynamic drag levels without knowing whether they're designing for a 20 horsepower gain or a 50 horsepower leap at Zandvoort, because each scenario demands fundamentally different trade-offs in packaging and efficiency. Motorsport Wheat and Motor Biscuit both reported that Honda hit internal targets ahead of the Dutch Grand Prix debut, but notably neither outlet could independently verify what those targets actually were in absolute terms. Internal targets could mean closing half the gap to midfield, or they could mean achieving reliability milestones that have nothing to do with peak output whatsoever. The distinction matters enormously for a team trying to break a curse, because hitting a reliability target doesn't move you up the timing sheets even if it keeps the car running long enough to collect cleaner data next time. Alonso's willingness to negotiate a €40 million annual salary extension despite this chaos suggests he sees something in the 2027 project that transcends current season metrics, perhaps recognizing that enduring this uncertainty now is the price of building something genuinely competitive under the new regulations. But for the engineers staring at conflicting data streams today, that long-term optimism doesn't resolve the immediate challenge of extracting performance from a power unit whose true capabilities remain partially hidden behind layers of unresolved mechanical dysfunction and unverified paddock speculation. The gap between what Honda says internally and what outsiders measure externally isn't just a communication problem. It's a structural barrier to development that no amount of driver talent or engineering brilliance can fully overcome until both sides share the same baseline truth about where they actually stand. Even if you grant Honda every single horsepower of deficit cited in the wildest paddock estimates, the math still leaves a massive chunk of unexplained lap time that points directly at chassis and correlation failures unrelated to power unit output. The race explicitly rejected the simple blame, the engine narrative for precisely this reason, arguing that the AMR26's fundamental aerodynamic shortcomings are just as significant a factor as the widely publicized mechanical struggles. Adrian Newey himself confirmed he had to change the whole car because the Honda engine didn't fit as originally packaged, meaning the entire chassis philosophy was compromised before the first test session even began. That admission reframes everything because it reveals the team wasn't optimizing around a known quantity, but rather reacting to physical constraints that emerged only after manufacturing had already commenced. Packaging failed early, redesign followed immediately, performance suffered inevitably. When your lead designer is forced into reactive architecture changes mid-development cycle, you lose the ability to pursue coherent aerodynamic concepts and instead end up with a vehicle shaped by compromise rather than vision. The 2026 regulations demanded unprecedented integration between the dramatically upscaled MGUK and the internal combustion engine, yet Aston Martin found themselves redesigning mounting points and cooling layouts around vibration mitigation rather than center of gravity optimization or airflow management.